Hi and welcome. I'm trying to learn histology, today tissue repair, and after we've done with it, we go on to stretching. And if you participate in stretching, then it's almost tissue repair. Tissue repair, and this is part 2, I think. I think once before. Tissue repair is the process in which worn out, damaged, or dead cells are replaced. Makes sense. They are damaged or dead or whatever cells, and they are replaced. Are sometimes also completely active and fit cells replaced? So basically the question is, are we just ever so often after a cycle replaced, or is there someone actually looking if it's necessary? Because the way we're showing it now here is that only worn or damaged and dead cells are replaced. Now the interesting question is, what is telling whom that it is damaged, worn out, or has to be replaced or dead? Now is the thing that or something. New cells originate by cell division from either the stroma, the supporting connective tissue, or the parenchyma, cells that constitute the tissues or organs functioning part. Okay, the cells are coming through cell division. So there's one cell and it divides and becoming two. And we are doing that from the stroma part. The stroma part is the part which gives the whole organ the structure or whatever else, and the parenchyma part is the thing doing the function inside of the organ. Cells that constitute the... I'm going to use now another example, the lung example. Maybe I'm not completely right about it, but I see it like that. The lung is the big lung on the outside with like an air balloon. That is the stroma part. And now the functioning part are the alveoli inside of the lungs, which are doing the carbon dioxide breathing, whatever it's called, oxygen, or whatever it's called. And because we had in the upper part here the fibrosis, so basically we understood it in the way, in the last histology part, that sometimes if something is damaged, the repair is just happening, but it can be that something is repaired by the stroma part or something like that, and the stroma part is now structuring, so it is not doing the functioning part. So the damage is very immense at the structure part and the parenchyma part, at all parts, and the stroma part is now starting to repair the functioning part, but it cannot function because it is not able to produce functioning parts. My analogy was then a house which is damaged so much from the outside that the walls are threatening to fall in, that the roof is falling in, and someone is building a pillar in the middle of the room to support the roof if the roof is not falling in. And now in the middle of the room a pillar is standing, the stroma part has built because the damage was so grave that it could fall in. This pillar, now the room is not really functioning anymore because the pillar is standing in the building. That is the way I understood it. I don't know if it's completely true, but that is the thing. And now either from stroma or the parenchyma part, there is now a cell dividing to replace the old, worn out, dead or damaged cell. In adults, each of the 4 basic tissue types, epithelial, connective, muscle and nervous, has a different capacity for replenishing parenchymal cells lost by damage, disease or other process. I don't understand the word replenishing. I get more and more a sense what it means. I heard it on 2 or 3 times, but replenishing. Where does the word come from? It is so long, and it probably means just a very little thing, just a small process, and there's so many letters. It's unusual for a normal thing that it has so many letters. Most of the times things just happen all of the time. I have very short words, and only more complex things have longer words, because these are words which are brought together out of different pieces, because it's something new invented basically, which is not really existing. And I think that replenishing means something which happens every day in completely normal day. Why does it have not its completely own word, not with another one together? That just its completely own word for itself. Whatever, replenishing. They are epithelial, connective, muscle and nervous cells. The epithelial, I say, we're in the skin, wherever now. The connective part, that is the part which holds all the organs together, that is somehow everywhere and holds everything together, like a mesh or whatever. And there's now the muscle tissue, these are muscles basically, and the nervous system, these are the nerves there somewhere. And now we're basically here to find out, the idea is we're making a ranking. In the ranking video about it, so we don't have to understand completely what is happening, we're just going to make a ranking. How good is connective tissue, and why muscle tissue, nervous tissue, and epithelial tissue. Now, in all these 4 have different capacity for replenishing the parenchymal cells lost by damage, disease, or other processes. Epithelial cells, which endure considerable wear and tear and even injury in some locations, have a continuous capacity for renewal. Okay, the epithelial cell. I'm going to say these are skin cells, but maybe not. In some cases, immature and undifferentiated cells called stem cells divide to replace lost or damaged cells. For example, stem cells reside in protected locations in the epithelia of the skin and gastrointestinal tract to replenish cells slaughtered from the apical surface, and stem cells in the red bone marrow continually provide new red and white blood cells and platelets. In some other cases, mature differentiated cells can undergo cell division. Examples are hepatocytes in the liver cells and endothelial cells in blood vessels. But have a continuous capacity for renewal. But we're not saying it is perfect. The idea is basically why aren't scars forming? Maybe it is that the skin can form ever and ever again. But maybe can still get a scar. It makes sense. It would be both possible. Okay, the epithelial cells may have an ability to do that, and in some cases, immature, undifferentiated cells called stem cells. When we're saying in some cases immature and undifferentiated cells, is there a certain amount of them and they are then used? Are these stem cells produced? They are dividing to replace lost or damaged cells. Are these stem cells also replacing other types of cells instead of epithelial cells? For example, stem cells reside in protected locations in the epithelia of the skin and the gastrointestinal tract to replenish cells slaughtered from the apical surface. And stem cells in red bone marrow continually provide new red and white blood cells and platelets. Is it now part of the epithelial cells? But red and white blood cells are not epithelial. Maybe it was just an additional information. In other cases, mature, so we have just immature, undifferentiated cells called stem cells, and now we're having mature, differentiated cells can undergo cell division. Examples are hepatocytes, liver cells, and endothelial cells and blood vessels. Are we now part of epithelial cells? Endothelial cells, epithelial, endothelial. Let's read on. Some connective tissues also have a continuous capacity for renewal. One example is bone, which has an ample blood supply. Other connective tissues, such as cartilage or fibrous connective tissue, can replenish cells less rapidly, in part because of smaller blood supply. Bone is also regenerated, or replenished, whatever it now means. And cartilage as well, just slower because the blood supply is slower. Why is cartilage less blood supply than bone? Why is bone with all blood supply? What would happen to a bone if it doesn't have blood supply? How does it look like? Is there a disease which doesn't? Muscle tissue has a relatively poor capacity for renewal of lost cells. I think that is interesting because muscles are so often injured. And I don't think muscle injuries are taken as serious as bone injuries, by far not. Maybe it is because the function is actually a bit big now. But the other thing is, I heard about actual completely tears or ruptures of muscles, and they seem to be more complicated than bones broke. They took way longer, many months, and bones took many weeks, but muscles many months. Okay, it could be actually true. This is an interesting thing. Muscle versus bone ruptures. Let's read the end, and we have no time to go through it now. Muscle tissue has a relatively poor capacity for renewal of lost cells. Existing cardiac muscle fibers cannot divide to form new fibers. Existing cardiac muscle fibers cannot divide to form new fibers. I want to know more about it. Even though skeletal muscle tissue contains stem cells called satellite cells, they do not divide rapidly enough to replace extensively damaged fibers. Smooth muscle fibers proliferate to some extent, but they do so much more slowly than the cells of epithelial connective tissue. Nervous tissue has the poorest capacity for renewal. Although experiments have recently revealed the presence of some stem cells in the brain, they normally do not undergo mitosis to replace damaged neurons. Discovering why this is so is a major goal of researchers seeking way to encourage the repair of damaged or diseased nervous tissue. That book is somewhere around 2000. Okay, whatever, we're going to read that whole thing again. That means that was a part of the histology now. If you were here for histology, you can go directly to the next part of histology. We will do more short stretching. If you participate in stretching inside of the outer skin. Next extension of the part we're breathing in the outside. And breathe out, over to one side. Breathe in into the middle. Out over to the other side. In into the middle. Out the arms down. Breathe again in. And out one hand slides down the leg. And the other shoulder stays down. Breathe again in. And out one elbow. Breathe in and out rib cage. And out back into the middle. Breathe again in. And out one hand slides down the leg, the other shoulder stays down. Breathe again in. And out we're taking one arm over. Breathe in and out rib cage. And out and down. And now if the legs stand together, breathe in, lift the arms up. And breathe out one hand down. And breathe in and reach. And breathe out one hand up. Breathe again in. And out with one hand down. Breathe in and reach to both ends. And out, hand up, and again down. Now if the legs stand shoulder wide apart, and we do shoulder circles, go back. Up, and front, and down. Back. Up, and front, and down. And again, front. Up, back, and down. Front. Up, back, and down. And now breathe in, lift the shoulders up. Breathe out, lift the shoulders down. Again in. And out. Again in. And out. Now in, and the arms up, we're doing the apple plucker. Reach high with one arm at a time. Pretend to take an apple hanging high on the apple branch, to turn it a bit around, and do it out. And last two. Now on to the shifter. Next one apart, arms up to a T, breathe in. And out, go out to one side. Breathe in. Out to the middle. And out to the other side. Breathe again in. Out to the middle. And out to the other side. Again in into the middle. And out to one side. Again in. And out, lean onto the legs. The buffalo fighting its hangover. Breathe again in. And out one shoulder in front. In the shoulder back. Out the other one in front. In the shoulder back. Out one shoulder in front. In the back. Out the other one in front. Breathe in the back. And out as we're hanging down, we're doing the Niagara Falls. We're just hanging down. And breathe again in. And out. Again in. And out over to one leg. Breathe again in. One over to the other leg. Again in. And out into the leg. And now with center engine. Bring the feet together. And breathing in. And out. Again in. And out. And again in. And out comes slowly a little back up and back at the top and backwards. Shoulder down. Bounce the toes up onto the outside. Order length space between the heels. Breathe in as the arms up. And breathe out and sink down. Elbows against the inside of the knees. And breathe in and straighten the back up. And breathe out and come the back up. Again in. And out back into the pose. Breathe in and straighten up. And out come to one straight line slowly upwards. And hands down. Now legs wide apart, breathe in and go down. And breathe out. Get in. And out. Get in. and out. Breathe in across the legs. And breathe out, hands down. And also stretching. I thank you very much, and until next time.